Morning, guys. So on today's e-learning worksheet, you have 10 questions where you have to classify numbers, whether they're whole numbers or integers or rational numbers, or if they're maybe could be a mixture of those three, or if they're irrational numbers. So I just want to give some clarification on this. Whole numbers are your positive numbers plus zero, that you're counting numbers. So starting at 0, 1, 2, 3, 4, 5, all the way up to infinity. And then the integers are all those numbers, all the positive numbers plus zero, and then all the negative numbers as well, the negative counting numbers. So those are what integers are. We just did a chapter over integers where we worked with positives and negatives. So if a number is a whole number, like 3, it's also included in the integers category. Okay. Now the interesting one down here, I don't know if you can see this square root 4. The square root of 4, the square root of a number is, remember when you square root a number, we're thinking what number squared gives me this number. So what number squared gives us 4? It's 2 squared. So then my square root of 4 would just be 2. And so because square root of 4 equals 2, I would classify it as a whole number. I'd also classify it as an integer because a positive counting number is still an integer. And I would classify it as a rational number. So any number that is a whole number, you classify as all 3. And there's an example of that on your worksheet. If you have a negative counting number, you would classify it as an integer in a rational number, but you wouldn't count it as a whole number. And then if you have a fraction or a decimal, you can see 27/4 is a fraction, -6/7 is a fraction, 4.5 is what we call a terminating decimal, one that stops. We know we've actually worked with writing these as fractions and mixed numbers, so we know we can write 4.5. And then 0.3 repeating, as long as it repeats, you can write it as a rational number. So rational numbers are numbers that can be written as fractions, and all these numbers in this box here can be written as fractions. So repeating decimals can be written as fractions, and terminating decimals can be written as fractions. The one type of decimal that cannot be written as a fraction is a number that looks like pi, which you see over here in the irrational box. Irrational numbers are decimals that go on forever without any repetition to them. So they don't terminate and they don't repeat. Now, pi is a great example of an irrational number, but actually any time that you square root a non-perfect square, you're also going to get an irrational number. You're going to get a decimal that goes on forever, no pattern to it. So although some square roots are okay, perfect squares, right? If you square root a perfect square like 1, 4, 9, 16, 25, 36, you're going to get nice whole numbers. But if you square root a non-perfect square like 2 or 17 or 11, you're going to end up with irrational numbers. So if you get a problem that has a square root symbol and it's a non-perfect square, think of it as looking like pi, an irrational number. Let me know if you have any questions over this. And this worksheet is due on Friday. Don't forget there's problems where you have to turn fractions to decimals by doing long division, top divided by bottom. And then there's problems where you have to turn fractions, decimals into fractions by writing that number over its place value and reducing. And so I'd refer you back to your 2.1 notes for another more examples of those, or you can email me if you have any questions. Good luck today, guys.